Good evening and welcome to the ASV's International Observe the Moon Night. Before we start, I'd like to say that in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to the land, sea and community, and we pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander people today. Tonight, the ASV is proud to bring you our live stream International Observe the Moon Night. As always, if you're enjoying tonight's stream on Facebook, you can donate stars. If you're on YouTube, you can donate stickers. All donations, no matter how large or small, are welcome. And if you're watching us for the first time, don't forget to subscribe on YouTube and like our page on Facebook. We hope you enjoyed tonight's stream. And I would like to make you aware that, as usual, being in Victoria, we are dodging some clouds. So we apologise in advance if you were unable to see the moon. And before we begin streaming the moon, I'll bring in the team that is going to be helping us stream tonight. And then we're going to announce the winner of our photography competition, of our moon photography competition. So we have Lee with us tonight. We have Barry. We have Andy. We have our planetary section director, Stuart Beveridge, with us. We have Steve Thurn.
Evening, everyone.
With us as well. And we have Gerald from Optic Central, who's going to be announcing the prize. So, Gerald, I think what we're going to do straight up is hand over to you. So, if you'd like to, the pressure's on you now to make somebody very happy. Well, make two people very happy.
Two people happy, yeah.
And everyone else will come for you. So, over to you now, Gerald.
Okay, to me. Thank you to everyone. There was some amazing photographs that I had to look through the past few days. Yeah, just some very creative shots and some very precise technical stuff. So there's two categories. The first category I'm going to look at was the creativity aspect of the competition. So I'll get straight into it. The winner is what's her name? Kylie McKay. She did this shot. I don't know if you can actually get this mark, but
you'll have to share your screen.
I'll try to share. There we go.
There we go.
Yeah, I chose this shot purely because it was to me it's nothing like I've seen before. It's to me it was quite a moody shot, and having that rainbow too. It was, emphasised it's been raining and still getting the moon. I thought that was quite well composed, and I enjoyed that. So that was a clear winner.
So this is for our membership.
This is the 1 year membership. Yeah, that's right.
This is for Kylie McKay. You could send us a message. We'll make an announcement as well on our Facebook page, and we'll organise and set up a membership for you in the coming days. So that's a 1 year membership to the Astronomical Society of Victoria. And who was the winner of the binoculars?
The binoculars. Right. I'll share my screen again. So this was a photo from Raf Serrano.
Okay, let's get that one up. Here we go.
I think this is an incredible shot. I mean, for me, it's captured so much detail, so much contrast, and it's also picking up the colours that of the minerals on the moon. So for me, that's technically a clear winner, and I think a well-deserved winner of the binoculars.
Right.
There we go, Raph. We'll tag you in the post, and if you could send us a message, we'll make sure we can get those binoculars out to you.
Yeah. So to everyone else, I mean, there were some great photos that were submitted. And, it was quite hard to pull a winner, but I went back and forth with a couple, but this one kept I think this photo here by Raf was one that to me stood out.
We'll pop that back up for a second. It's a very nice photo, very well composed, well taken as well. There we go. It is. It's a very impressive photo, this one, that's for sure.
I like even outside of the sort of the mineral colouring.
Yes.
Further down, the fact that you've got the craters with the ejecta lines,
yeah,
are really quite highlighted.
Very sharp, very good photo. Now, I think we might actually have a little bit of cloud just for the moment. So what I'm going to do is I'd like to explain a little bit about the moon, and if anyone has any questions, feel free to pop them in the chat and we'll answer them as best we can. So as an introduction to the moon is 3,476 kilometres across. It's about 1/4 the diameter of Earth and is the 5th largest moon in the solar system. Doesn't even get the title of the largest moon. The moon orbits the Earth every 27.5 days, which is a sidereal month, at an average distance of 384,000 kilometres. The orbit is slightly elliptical, with the minimum distance, perigee, at 360,000 kilometres and the maximum distance, apogee, at 400,000 kilometres. It spins on its axis at the same rate as it revolves around the Earth, hence why we always see the same face of the moon. The most likely origin of the moon is a giant impact where a Mars-sized planet smashed into the young Earth, forming a cloud of debris in near-Earth orbit, which eventually coalesced to form the moon. The moon rocks returned by Apollo astronauts show us the moon has existed for about 4.6 billion years. A full lunar phase cycle takes 29.5 days, and due to that fact, the Earth is also moving around the sun, and the moon is currently in its waxing gibbous phase? Oh, that might not be right.
Correct.
Yes,
lie.
Yeah, that's correct.
It
is waxing gibbous. I
was on
myself for a second there. And a new moon when the moon lies between Earth and the sun's rays. So all we see is the unilluminated side of the moon. The full moon is when the moon lies on the far side of the Earth and the sun's rays. So we see it fully illuminated. At full moon, the moon rises in the east at the same time as the sun sets in the west. And with a waning moon, after full moon, when the moon lies off to the side of Earth and the sun's rays, each day we see a shrinking gibbous moon, followed at last quarter by a shrinking crescent moon as it heads towards new moon. Now, look at that. We have a live feed.
Ooh, look at that.
So this is from Andy's. This is Andy. Andy's over near the South Australian border. Now, Andy, you can't zoom in on that at the moment, can you?
No, not at the moment. I've just got one camera in, but I'll get my other one in. I've got my guide scope. That's my guide scope. I can sort of zoom in on that, but it's not the clearest thing. But yeah, I'll get my other camera on in a minute. Yeah, it's in and out of cloud, of course, like normal. She's gone straight behind now.
We did mention to the viewers that we'd be battling cloud. So we were hoping to have a look at Copernicus, the crater Copernicus first up. So Steve, I might see if you want to have a chat about Copernicus, even though we can't quite see it at the moment.
Well, what about instead of doing Copernicus, we could perhaps talk about the mare, the seas, which we can. So the dark patches.
Yes, let's do that. Oh, actually, no, let's go there because Noel's got Copernicus. He's going to share his screen in a second for us, and you'll be able to jump into Copernicus.
Oh,
bear with us. Here he comes. There we go.
There we go. Look at those ejecta rays.
Right on cue.
Wow. So the reason so Copernicus is one of the younger craters on the moon. It was formed in the Copernican period. So that period of crater development on the moon is named after Copernicus. So it's one of the younger craters. So they think it was formed around 900 million years ago. So about 1 billion years ago. So most of the crater activity on the moon predates Copernicus, which is happened 900 million years ago. That's a really good picture of it. You can see the mountain, two mountains in the center of Copernicus there. So Copernicus is 93 kilometers across. And just to give you an idea of, so that's a sort of a horizontal scale idea, a little bit of sort of vertical scale. So the surface of the crater down in the middle is 3,750 meters below the rim. And the central mountains that you can see, the two there, are 1,000 meters high. They don't look it, do they? They look like just little pimples, but they're 1,000 meters high. So heading for sort of half the height of the highest mountains in Australia. I don't know if we can see as well. If you zoom out a little bit, can we see the keyhole-shaped crater? I get my teeth in. The keyhole-shaped crater. Oh, there it is. You can see it just below. Can you see? I don't know if you can point. That little keyhole crater is called Fauth, F-A-U-T-H. So those are really good images that we're getting. I know last year when we were doing the International Observing the Moon Night, we couldn't get to this sort of quality of resolution. It's really good. Apparently, another little fact about Copernicus. There was a picture taken by the Lunar Orbiter, Lunar Orbiter 2, in 1966, all those many moons ago. When I was, how old would I have been? 9. I was 9. And what it did was it took a picture at a sort of an oblique angle across Copernicus. And apparently it was regarded as being the picture of the century for the 20th century. So the Lunar 2 orbiter was flying at about 130 kilometers above the surface when it took the picture. I don't know if we've got. I might try and. I haven't got a picture of that, but I might try and fish one out, and we can show it in a little while.
I might see, Barry, if you've got anything you'd like to add to the information about Copernicus that Steve's shared with us. There you go. You're right to talk now, Barry.
Okay, yeah, I've got a picture of it. If I could share that.
Yeah, by all means, share away. We can pop that up.
Where's the
little share button down the bottom, little plus.
Yep.
And while we've got that, while we're waiting for that to come up, Andy's got an image of the Apollo.
That's not it.
Apollo 11. Oh, hang on. We'll jump back. We'll come back to Andy's in a second. Oh. No, we'll go back. Barry's still trying to share his screen. You'll have to share the window you want to share. So, Andy, do you want to tell us a little bit about what we're looking at here?
Now, yeah, we're actually looking at the landing vehicle, the Eagle, which was landed in 1969, and that's the base of it. The top part of it has actually left and docked on. Now, this is not taken from Earth. It's taken from one of the orbiters which orbit the moon, and it's just a program anyone can download. But you can even see the footprints where they walk to the crater. I can't remember what crater this was called. They walked to the crater. They walked around here, but quite clearly you can see this. But these were taken probably 100 kilometres up, if that, probably even closer. So zoomed out, I will zoom out in the area where you can see in the Sea of Tranquility. Is it coming out a bit more? Right on the edge. So anyone can look at this. It's called Moon Trek. You just look for Moon Trek. It's a NASA, and it's a whole database of all their images they've taken, and you can do different layering. You can actually get gravity layers. Yeah, I love this. And it's also Mars as well, and the details you can get, but you can't see this from Earth. But anyway, it's a program you can play with sometime. You can see the brilliant details of craters. It just takes a while. I'm in my tent, so I'm not getting really good internet at the moment, so it'll take a while for these images to load, and they're pretty intensive. But you can, and I've searched everywhere, and I haven't found any crazy alien structures yet. So
No alien structures yet.
Hours on this, except for the bit which NASA won't show you. Haven't found any golf balls or hammers. I'm
going to jump over to Barry's screen because Barry wanted to chat a little bit more about Copernicus, and we've got his photo up. So Barry, take it away.
Is that photo up for everyone?
It is. Yes, we can see it.
Yep.
Yeah, I think it's hard to understand, but if you stand in the flat part of many of the craters on the moon and look towards the horizon, the actual mountains that form the crater are below the horizon, and that's due to the curvature of the moon itself. Now, I'm not quite sure whether that applies to Copernicus because those mountains look very, very high. But many of the other craters, like Plato, etc., filled up with a lava plain. You just can't see the crater itself by anyone standing in the middle. The walls are so far away that the curvature of the moon drops them out of sight. The peak in the middle of Copernicus, you can see, is not just a simple peak like you see a drop of water coming out of the sink. It's a very complex central peak, and I guess it's an indication of the catastrophic collision. But I haven't got a lot more to add about Copernicus. It's probably in the top 5 most prominent features on the moon as far as craters go, and if it clears up, we'll be able to see it live.
Hey Mark, Barry, I've found the picture of the century, which on the map, which I can kind of show. I think it kind of demonstrates what you were saying, Barry, which is that you can't really see just how high the edges of the crater are, even though obviously this picture of the century wasn't taken from the surface; it was taken from 130 kilometers up. So let me just see if I can find it.
Those images before from, was it Andy?
Yes.
Of the footprints and the lander. That was from the LRO, the Lunar Reconnaissance Orbiter of 2016, that took very high resolution images of the moon, and it was in an orbit that brought it down to 200 meters above the surface.
Yeah, that's why.
Yeah.
That's why you can't see it from Earth.
Yeah.
I think one pixel, even off the Hubble, 1 pixel is it's hundreds of meters. 1 pixel will not, the resolution won't pick up. I think it's easy, 100 square meters, 100 by 100 square meters minimum. So that's why it's blurry. That's why you won't pick anything up.
Mark, I've shared that image. I don't know whether you can bring it up or not.
There we go.
So what I find amazing about this picture is that it was taken in 1966. So I can understand why it was seen as being the picture of the century at the time. Apparently, this is not the original. It's a sort of a one that's been worked on a little bit, but you can actually see the sort of bands, how the picture was put together as sort of bands of image that they've sort of stitched together. Amazing. But the edges, obviously, of the crater don't really look that high. You know, when you think that there's a difference of what did I say, 3,750 meters from the bottom of Copernicus to the rim. Truly amazing.
That also would have been.
It's quite an impressive image for when it was taken. Right, so we're jumping across now to, well, Tycho. There we go. I'm going to throw that one back to you again, Steve, to kick off on.
Sure. So Tycho is just a mere baby of a crater in terms of its age. It's about 100 million years old. So Copernicus was, what did I say, 900 million years old. Tycho is about 100 million years old. And I think what people will know about that, so it's a little bit smaller than Copernicus. It's, what is it, 85 kilometers across. But the thing that I think people, when they look up at the moon, you can, I think you can see this with the naked eye, as obviously with binoculars, is the at full moon you can really see all of the ejecta rays that come out from Tycho and spread about halfway across the surface of the moon in all directions. It's a really spectacular sight. It's one of the things, you know, obviously when you're looking at the full moon, a lot of the detail is washed out, but what the brightness of the full moon does bring out is the ejecta rays of Tycho. It's really quite spectacular. So it's, I mean, the floor of Tycho is about 5 kilometers below the rim, so it's actually a bit deeper than Copernicus. And that little pimple in the middle is actually 1,600 meters high. Yeah.
Now, there is a question, and I'm not sure whether we're able to answer it. Nico's asking, how do they work out how old they are? Not sure if I can answer that one. I know I can't.
No, I mean, I'll defer to perhaps, I don't know if Stuart or Barry know, but I think what they've done over the years is to kind of work out how craters sit on top of one another. So you've got like the very early craters, and then they overlap one another and overlap one another. Sorry, Barry, go on.
Yeah, I was going to say much the same thing. There appears to be almost no young craters inside Tycho, and that's a clear indication that it's pretty young. I think if you do, if you could build up a catalogue of craters and overlaps of craters, you could eventually work out a timeline, and on that timeline, probably Tycho would sit right up at the the latest end of it.
So we do have another question as well, and this is probably the crater to look at to answer this one. Can we explain what ejecta rays are and what causes it?
Oh, the ejecta rays are material that's been ejected from the collision in a almost horizontal direction by the sheer blast of the formation of the crater, and they travel at such high velocity with such high energy that they carve a little furrow across, well, a big furrow across the surface of the moon. And they're most evident. You can actually see them in that picture off to the right of Tycho. You can point to them, probably, Mark, but I can't. Yeah, around there, there's evidence of streaks that you can see, probably radiating from Tycho itself.
So, Noel, I'm just wondering if you're able to maybe turn the brightness up a little bit to see if that makes the ejecta appear a bit more prominently, or the gain exposure. Not sure if the tech. There we go. Oh,
it's
too much. About there, so you can really see them there now. You can really see those lines. Yeah, perfect.
As opposed to what we've just been saying, below Tycho in that picture is the crater Clavius, and Clavius is thought to be the second largest crater on our side of the moon. But you can see inside it there's a parade of other craters, so that indicating that Clavius is quite an old crater, and that there's a couple of craters on the rim, and then that big arc of craters getting smaller and smaller to the left. So Clavius would be quite an old crater. Off the top of our heads, it would be difficult to actually put an age on it, but except to say it's much, much older than Tycho.
So I was just going to say, do we have any understanding of where those crater hits have come from? What direction they may have come from, or is it not something that we were able to tell?
I was on the understanding that arc of craters, and there's others similar on the moon as well, and other moons, is a rapid collision of pieces from the same object that may have partly broken up on its travels to the moon, and it's sort of almost like a machine gun parade of collisions. But
I think the good news for us living now is that there isn't as much stuff floating around the solar system as there would have been 100 million years ago. So the number of we just don't really see new large craters forming on the moon now. It's really just very small objects. All the significant activity that formed these craters is really in past history. And obviously Tycho is about 100 million years ago. Most of the activity that created the early craters, the really big ones, the dark ones, the Mare, occurred about 4 billion years ago. So when the solar system was really just forming.
Getting back to the question about the angle of the collision, I think if the angle is very oblique, the crater actually comes out to be elliptical. But if you study what appears to be a round crater, it's probably not as symmetrical as you may think, and there might be a deep end or a deep part on one side, or more build up of the mountain on one side than the other, and that would indicate that the collision was not perpendicular to the surface.
Mark, whose image is this? Because this looks spectacular.
This is live from Noel's equipment. This is up in Bendigo. So
Noel, this is spectacular.
Yeah, this is the only clear sky we've got at the moment, so we're rolling with it. So I think we might try and jump up to Sea of Tranquility next, if we can. Have a bit of a chat about the most famous sea, or Mare. I said it right, Steve. Are you proud?
Well done. You can call them mares if you want to. I'm okay with that.
I do like calling them mares. It sounds a little bit GG's. A little bit of fun.
That was Anne-Marie's issue earlier.
That was Anne-Marie's issue earlier, chasing
horses
that have
around the paddock.
escaped. There we go. We have astrophotographers with equipment all over Victoria. One of those being Anne Marie, who's sort of out Castlemaine, Malden way, and instead of being able to set up her gear for tonight, she was chasing horses that had escaped their paddocks. So we have all kinds of issues when we go for live streaming. And there you go, Noel. Margie says, thanks for sharing, Noel. Fantastic view.
So just to give you a bit of a we're on Knowles, aren't we? Are we on Knowles?
We are, yes.
So the Mare Tranquillitatis is the large sea, just sort of left of centre in the image there. The mare that's above it is the Sea of Serenity, Mare Serenitatis, and the virtually round mare just over to the on the right of the image there is Mare Crisium. So that just for those that sort of don't know what the mare are, as I said earlier on, they're very, very old impact basin craters that go back about between 3 and 4.3 billion years. That's when all of the mares were formed. And very early days with the moon, when it was still quite a sort of volatile, molten sort of object. So what happened was that a large meteor would have impacted and formed that huge great crater, which then almost immediately flooded with molten lava, a basaltic lava. That's why it has a sort of a dark colour. If you think of the rock basalt here on Earth, it's almost black, sort of dark grey colour, and it's the same sort of thing on the moon. Interesting thing as well is that it was very fluid, so it had the viscosity of motor oil. So it was able to flow very, very rapidly to fill the crater. And so a lot of the sort of the detail inside the crater was lost with this sort of flow of lava across. Of course, the Mare Tranquillitatis, the Sea of Tranquility, is probably most famous as being the place where man stepped foot on the moon for the first time with Apollo 11. And in this image, the area of the Sea of Tranquility where they landed is in the sort of the lower left part of the crater. I don't know whether you can sort of point out, Noel, where that is in that sort of lower left. Not into that little bottom bit that sort of goes away, just up a little bit higher. Where the bright dot is, that's a great way of describing it.
Can we see where the lunar lander landed?
Well,
I'm just getting in early. We do have a question about the lava flows. Did the lava flow from inside the moon or from an impact object? So was the moon volcanic when that lava flow occurred, or was it from something else?
So it's from the inside of the moon, as you put it there. So I would have anticipated that the actual meteor itself, a lot of the meteor would have sort of exploded away in the ejecta rays, like we have with the young craters like Tycho. But if you look at the scale of the Sea of Tranquility, it must have been a very, very violent episode. And you wouldn't have wanted to be very close to it.
I think I might have a question for Barry from one of our viewers. Raf, who is our binocular winner. Congratulations, Raf. Glad to have you on the stream. How come there are circular craters on the side of the moon facing Earth? Shouldn't Earth block any objects coming that way?
Well, I think for a start, something hitting the moon wouldn't come straight in. It would come in a curved trajectory. It would have been influenced by the moon's gravity itself as it got close. So also something coming from the direction of the Earth may, in fact, the Earth's gravity may in fact focus the object into hitting the moon. I think from a collision point of view, the Earth would represent quite a small impedance to the flow of these objects. So I don't think it would make a lot of difference.
There we go. Hopefully that answers your question, Raf. Stuart, do you have anything to add about the Sea of Tranquility there? Anything to do with the Apollo missions, perhaps?
No, just going on what Barry said. I don't think the Earth would have impeded any objects coming in, but the Moon at the moment is locked into its. Also, it's locked into its orbital rotational view, where we only see the one side, but it might not have necessarily always been that way until it reached the synchronous orbit that it is today.
Yeah.
Hopefully we've been able to answer those questions. I don't think we've got any others. No other questions at the moment. So if it's possible, and we might move to the Apennine Mountains if we can. No pressure, Noel. No pressure at all. I know Anne-Marie's got her scope up and running as well now. I might just jump across to Anne-Marie's quickly while we're...
Mark, if you want to go and share my screen again. I've got a very famous picture from Apollo 11.
Is that the one that was filmed taken in Hollywood by Stanley Kubrick?
It certainly was, yeah.
Yes,
Can you? I don't know if you can share that one up.
I have already.
In a Hollywood basement.
Okay,
yeah.
So this is a picture of Buzz Aldrin. So it's not Neil Armstrong. Well, it's actually both of them, because what's really, other than the fact that it's a really great sharp picture, what you can see in Buzz Aldrin's visor, you can actually see a reflection of Neil Armstrong in the middle, and also the Eagle, the lunar lander, reflected in the visor of Buzz Aldrin's spacesuit. It's just an amazing picture. It also proved once and for all that the Mare Tranquillitatis was not a sea. So they are not paddling in water. They are jumping around in the regolith on the surface of the moon.
We'll jump back across to Anne-Marie's quickly here. So I'm trying to work out where we are on there with that. I think we're still near. We're near Serenity and Tranquility. I believe. Looks to me like that's where we are.
So the Apennine Mountains are top right.
They are too. There we go. On the money, Anne-Marie. On the money. So we might have a chat about the Apennine Mountains, the mountain range. I know they're named after the Italian mountains, the Apennine Mountains in Italy.
Have you been there?
Sorry?
Have you been to the Apennine?
No. Up Anne-Marie. Oh, yeah, there we go. Bang on the money. No, I haven't. I'd love to, though. I really would love to. They're quite beautiful, these ones. I'd like to go to these ones as well one day if we could.
But it's interesting because the Montes Apennines are so much higher than anything that we've got in Australia. So they're about 5,000 meters tall, the tallest part. So what have we got? We've got just over 2,000 meters with Kosciuszko. So they're actually more akin to the mountains that you would see in Europe, particularly, say, the Alps, which go up to that sort of height. So they're a significant range of mountains. My notes say that the mountain range is about 250 kilometers long. I'm not sure about that, actually. I thought they were a bit longer.
Well, while you confirm that, I'm not sure. I'm hoping Amber might be able to, or somebody might be able to. Justin wants to know, what scale are we looking at here? How many kilometres across the screen? So if the mountains are meant to be about 250 kilometres, they're taking up probably almost half of that view there on the left-hand side, that would make the width of that screen there, close to 600 kilometres across?
And that for some reason, that was a figure that I was thinking.
I feel like that's not right. I feel like it's wider than that.
Well, the bright crater, which is Aristoteles, is 87 kilometres wide. So I'm thinking we're looking at more at 600 kilometres rather than 250, aren't we, for the mountain?
Yeah, and I think the width of that view there, we're probably looking close to 1,000 kilometres across.
Yeah.
Yeah, even more.
Maybe more, yep.
1,200.
1,200? There we go. Around about 1,200 kilometres across the current view that we've got now, approximately. We have another question from Rebecca on YouTube. Wants to know, how long will it take for the moon to break away from Earth's gravity and venture off into space?
Yeah, the dynamics of celestial objects is incredibly complicated, and a simple answer is that it may never do so. It may actually collide with the Earth rather than disappear. But it's all to do with maintenance of momentum and kinetic energy and the rest of it. At the moment, the moon is actually slightly moving away, is it? Or have I got that right?
Yeah. Something like 3 centimetres a year or something.
Yeah, 2 or 3 centimetres a year, that's right.
But it doesn't mean that it will do that forever. And there are also perturbations from other planets in the solar system that have an influence on the movement of the Earth, of the moon around the Earth, and to predict its actual motion millions or even billions of years down the track is incredibly complicated. But it may never break away from the Earth.
Well, I kind of hope not, because I love getting out and imaging it. It's great fun. Here's another one. Not sure we can answer this one, but we'll give it a go. Hi all, is there still much research happening with respect to the moon, and could you share any upcoming projects, missions planned, if any? I believe there was one announced today to do with Australian Space Research and NASA. Something along those lines.
There's a moon buggy that was announced today from Australia that's going to be, I don't know too much about it, but in cohorts with NASA, there's a new moon little buggy that's going to go up to the moon, but I'm not sure exactly when. I'd have to go back and reread the article.
So yeah, that's about the only one that I know. I know China's got some stuff happening up there. Not exactly sure on the details.
It's something in the order of 2026.
For the Australian
rover. Yeah, that's correct. Yeah.
For those who are interested in their Apollo facts, Apollo 15 landed in fairly close to the Apennine Mountains. So in this image that we've got here, you can see where there's a sort of towards the sort of top end, there's a sort of gap between the mountains. So on the top side, that gap just down, sort of near where that small bright crater is, but closer to the mountains, that's where Apollo 15 landed, near to the Hadley Rill.
So
Another excellent image of the moon.
It's really good, isn't it?
So we got Cigar saying India are also sending up Chandrayaan to the moon. So there's quite a lot of things happening coming up on the moon, that's for sure.
You know, earlier on we were, I think you said, Mark, that the moon is about 4.5 billion years old. So it's orbiting the Earth. I think you said something like that.
Something like that.
When William Shatner went up into Earth orbit, did he become the oldest object orbiting the Earth?
Well, he's about 4.5 billion years old.
Yeah, so. I was kind of thinking that.
No, he's the oldest astronaut.
Yeah.
Oh, okay.
He is about 4.5 billion years old, so he could well have been close to the. Yeah.
Even when John Glenn went up the second time, he was 78 or 79 years old, something like that. So William Shatner has really blown that record.
Yes. But the man in the moon is by far the oldest to be orbiting the Earth.
So there we go. China's Chang'e 5 mission has sent back its first colour photos. I do remember that. I remember seeing that in the news, so that's why I sort of hinted. I couldn't remember exactly what it was called though. So thank you, Chris, for clarifying that for us.
They were from the other side too, weren't they?
Yeah,
far
that was
side?
from the far. That was from the far side. Yeah.
I like to call it the dark side of the moon. It's so much more fun.
So Pink Floyd of you.
So Pink Floyd of me, I know. I can't help
Only
it.
if you like Pink Floyd.
Well, I do. Now, Barry was mentioning something this afternoon at the ASV's instrument making section about the sun and the moon and the difference in brightness, which I thought was seriously interesting. And I'd love for Barry to explain it to the viewers.
If I can get it going.
Oh, you're going to share your spread? Oh, wonderful. Cool. All right. While
That was a really good talk.
It was, wasn't it? Here we go. It's a little bit of an inside running on what happens in section meetings that some of these viewers don't get to see. So Barry gave a talk on the sun today, and there was a little bit of discussion about the sun and the moon. So take it away, Barry.
Well, good evening, everyone. Yeah, we were talking this afternoon about how we can go about photographing the sun and using telescopes with uncoated optics, reflectors with no coating on the glass to attenuate the light. And I brought up a couple of interesting facts that you may be interested in. There's a picture of the sun, and in astronomy, we measure the brightness of objects by what we call the magnitude. And the magnitude of the sun is recognised to be minus 26.7. Now, I know someone will write a question, how do you measure the magnitude of the sun? Well, it's all to do with the gathering the energy all together and with instruments that measure such things. That's a picture of the moon. I've made it much the same size. If it was over the top of the sun, it would be an eclipse. But the magnitude of the moon is at minus 12.7. Now, the difference being a difference of 14 magnitudes. In astronomy, the magnitude is a logarithmic scale, and if we consider a brightness difference of 100, then that corresponds to a magnitude difference of 5. Right? Where 5 magnitudes represents a difference in brightness of 100. So the question is, what brightness difference does 1 magnitude represent? And we can find that by finding the 5th root of 100, and that comes out to a figure of 2.512. Now that figure is telling me that if we have a star of magnitude 2, then a star of magnitude 1 will be 2.512 times brighter. If we have if we find a star of magnitude 3, then our first magnitude star would be 2.512 squared brighter than magnitude 3. So we can find out using that procedure just how much brighter the sun is than the moon. So in 14 magnitudes represents a brightness difference of 2.512 to the power of 14. That's the difference in magnitude. And that comes to 398,107. And putting it bluntly, we can say that the sun is 400,000 times brighter than the full moon. Doesn't matter whether it's a super moon or not. The full moon is quite bright. If you go out and have a look at it, you can read the paper by it and do all sorts of things. But the sun is 400,000 times brighter than the full moon. And the simple message is, don't look at the sun.
Unless you've got some serious sunglasses.
So there you go. I just thought it was very interesting how much brighter the sun is than the moon. Considering how bright the moon can be to look at through an eyepiece of a telescope when it's a full moon, it is quite bright, and it's quite like you lose your night vision very quickly looking at the moon, a full moon, or any even like a quarter moon. It's very bright on the eye, and then to see that the sun is that much brighter.
I think the problem is that people know that we can actually look at the sun with very special equipment, and the warning is that the equipment, it really is very special, and that you shouldn't try and preempt what you can do without some very good advice on what you can do and what you can't do, and the consequence is that you'll have some very, very serious eye damage if you I know this night is not about looking at the sun. Perhaps one day we can have a session on looking at the sun, but
we most definitely can.
Yeah, but just sufficient for tonight to say it is incredibly dangerous. Don't look at the sun. The sun is 400,000 times brighter than the full moon.
Yeah. And I think the other thing that explains, Barry, is it gives a good representation of why the moon is so bright when it's a full moon.
Yeah,
because it's got that much. Impressive.
Yeah.
So thank you for those stats. So we're going to have a quick look at Anne-Marie's full moon there. Oh no, she's zoomed back in on the other one. Right, there we go. So I say full moon, but a full view of the moon, while Noel skips across to Mare, what they say was I'll let him know, Mare Frigoris and Imbrium. So this is a nice view of what you would see outside right now if there were no clouds. And if you're in Bendigo or out near where Anne-Marie is, this is what you'd be seeing. If you're in Melbourne, according to Lee, in Ringwood, you'd see nothing but cloud, which he's very grumpy about.
Yep.
Every time we do a live stream, it's cloudy in Ringwood. It's almost like it's trying to tell you something.
Someone keeps buying gear. It's got to be that, at least.
It has to be.
Only in East Ringwood.
East Ringwood, yeah. Well, is it cloudy where you are, Stu? You're only a stone's throw from me.
Probably.
Yeah, so.
I've actually watched the forms over the top of us.
Anne-Marie's actually got Mare Frigoris and Imbrium, the area that I was talking about, up at the moment, so we'll jump over to there.
I think it's the area. I'm not sure.
I'm just looking at Knowles off the side there, and it's probably...
So Imbrius is the larger, the larger
so not
one.
Quite the right area. I think more...
Isn't it over there?
We'll jump across to Knowles and then we'll see if that's it.
Okay.
There we go. So Knowles got it. It's got that lovely crater stuck in between the two of them.
Yeah.
Towards the South Pole.
Yes. So, Steve, you'd like to take it away? Floor is yours again.
I'm not sure I've got very much detail on any of this. I don't know if anyone else wants to chip in. I'm just trying to work out where we are actually. So what's the?
That's Plato in the middle. Plato and down to the lower right is the Alpine Valley.
Take it away, Barry. any other stats you can add into that, that'd be great.
Plato was around about the same size as, well, probably a little bit bigger than Copernicus, but it's a crater that is actually filled up. It's probably a very old crater, and it is filled up with lava due to the collision that was probably just next door to it. And if you look at the bottom of Plato, you can actually see many craters, but you can see them best under a certain elevation of the sun. If the sun is too oblique, they're not easy to see. And that's one of the craters that I was referring to before. That if you stand in the middle of Plato, then the rim of the crater is totally invisible due to the curvature of the moon.
Yeah, so Plato is 3.84 billion years old, according to Dr. Google.
So it's younger than Bill Shatner.
Yes, and it's 101 kilometers across. But you can, as Barry said, you can see it's a very old crater because it's full of lava. There's no detail at all. You can't see any of those sort of, particularly around the crater edges. On a new crater, you would see those sort of like ridges of the edges of the crater dropping down into the centre. There's none of that at all. It's all, well, it looks almost flat. It isn't almost flat, obviously.
It kind of does almost look flat, doesn't it? Almost like it's about to overflow.
Yeah.
So I have a couple of questions here for you guys. Bob wants to know, if humans start using the moon as a base to launch rockets, will this slightly change the orbit distance? If so, is it anything to worry about? I'd be a bit concerned if we're putting rockets on the moon to start with, but hypothetically speaking, would it cause an issue with the orbit of the moon?
I think in a word, no.
No, there we go.
No, the moon's a good place to launch rockets from because the gravity is only 1/6 of the Earth, and therefore it only requires a lot less energy and a lot less fuel.
I remember the pictures that they showed of some of the Apollo missions. I think it was the later ones, of just how, when they push the go button to come back home, just how quickly the top part of the lander actually escapes.
So there was an interesting one that I'd like to answer by Raf. He wanted to know, are there any plans for moon base? Raf, it's not a moon base, it's a space station. Sorry, a little bit of Star Wars in there. But there's one for the photographers out there. Chris wants to know, is it true that to take a simple photo of the moon, you set exposure for bright day photo on Earth, ISO 100, 1/60th of a second, f8?
Pretty much.
Pretty much? Bang on the money?
Close.
Close. What would you do, Anne-Marie?
Something similar.
That doesn't. Something similar. What would you have the settings at?
You could start there, and then you would just change. If it's too dark, move your ISO up a bit. At 1/160th, you're going to get a bit of camera shake though, so a tripod would be good. Yeah, I'd probably actually even make it about 125, 125, rather than 1/60th. But you just play with them. F8 sounds about right.
Yep. Well, there we go, Chris. Test it out and
start with that.
Start with that and throw some of your examples on our Facebook page or send them to us in a message, and we'll let you know how we think you've gone.
Certainly could come down to the lens and the camera being used as well.
So I'm just trying to see, we've got a couple other questions here. Nico, Plato doesn't have any smaller craters, so given the aging technique discussed before, it would be young rather than old. And I think we were saying that's actually...
Hang on, there are small craters in the bottom of Plato, but the big craters like Clavius, they've all been filled in with this lava.
Yeah, so this one's an old
It's possible
crater.
that it was a very, very old crater, and a lot of the detail of it of the original plateau has been filled up with this lava lake. Then on top of that, there are small craters that you can see. As it is now, you can actually see craters on the surface of Plato.
Yeah, I've got a very detailed picture of Plato, and you can see there are a number of small craters across the lake. But it is an interesting one. I mean, it's Plato being a very old crater, 3.84 billion years. It seems to have done remarkably well to escape being impacted by newer meteors coming in, and as has happened with a lot of the other craters, particularly the older ones. So it seems to have escaped all of that.
Yeah, I've got an image of it with lots of little craters in it as well.
So Chris is coming back to the photography. So I'm assuming he's got a phone that he wants to use and do that with. So that would be my area of expertise. And it's almost the same as what Anne-Marie said. That would be close to where I would start with. But I use a tripod when I take my photos of the moon with my phone, and I use a little Bluetooth clicker, so I don't have to worry about the shake that Anne-Marie was talking about if you're holding it. But yeah, it's a matter of suck it and see. Give it a go. Change the settings. Kick the ISO up, drop it down, change settings, lengths of exposure. I know when I'm using my telescope and I've got the phone attached to it, I drop the ISO right down to 50 because otherwise it comes out sometimes far too white. So it's a testing. Just test. Just keep trying different settings, and with phones are very different to digital SLRs, that's for sure. And every phone is different in how it has to be set up as well. Hopefully that was. Here we go, Nico. Are we looking at the moon right now in these images? Yes, this is live. This is actually the moon as it is being seen tonight, all the way from Cozy Bendigo.
About 3 seconds old.
About 3 seconds old. And why is it 3 seconds old, Stuart?
Because that's the time it takes for the speed of light to reach the Earth.
There we go. So we're looking back in time at the moon by 3 seconds. It's pretty cool when you think about it.
I think it's 3 seconds.
Is it live or filmed in your studio? Unfortunately, Stanley Kubrick couldn't be with us here tonight, so no, it's live.
I think he might be in jail.
We won't go there. We'll leave that one alone. I think what we're on Lee's. Sorry, not Lee's. Lee's got cloud, but he says it's clearing. We're on Knowles at the moment, and he's trying to get for us. He's trying to get for us Aristarchus to come up. He might be on the edge of the shadow, may not. So we'll see how he goes. See if he can get that for us. So it's a lunar impact crater in the northwest part of the moon near the side. It's considered the brightest of the large formations on the lunar surface. So it's quite an impressive crater, and he's going to try and... No, it's hidden. So he's not going to be able to get it, unfortunately. We're getting questions all over the shop about lunar landers, or has a decision been made as to where the next landing on the moon will be? Has anybody had any information come to hand on that one that they know of?
Yeah, not that I know of.
Yeah, I don't know either, no.
Go jump back over. So I don't know either. I haven't heard anything. Unfortunately, there's so many things happening at the moment. It's very hard to keep up with everything that's going on. That's for sure. So
where they need to land if they're going to stay there for any time is they need to have water. So water can be broken up, as most people know, it's H2O, into oxygen and hydrogen. And If you land there and you can extract the water, that means you don't have to carry it, because water is very heavy to transport with a spacecraft, so it uses a lot of fuel. So if you can land somewhere and you know there's water there, you can use the water to drink, and then you can also make rocket fuel and oxygen.
So hang on, we're
Yeah,
going
well,
to jump over. We're going to jump across
the
to
good news is
Andy's. Sorry, Barry, go for it. You go.
I was just going to say the good news is that there's thought to be water in the bottom of craters very close to the poles of the moon. But the bad news is that getting astronauts in what is almost a polar orbit is not easy. It's a bit like Juno going around Jupiter. It was a very complicated series of rocket blasts to get into a polar orbit. So landing astronauts near the poles of the moon will not be easy.
No, that's right.
We have another question. Can we also explain a bit about the moon's atmosphere, please? Or lack thereof?
Yeah, I think it's almost non-existent.
Almost. So when you say almost, is there any atmosphere on the moon at all?
I've not seen anything written much about an atmosphere. I know that Mercury is said to have no atmosphere, but then it's been calculated to have an atmosphere of about a centimetre high, which is almost ridiculous. But
I don't think that if there is an atmosphere, Barry, I think it's so thin that all the astronauts' footprints are expected to last for millions of years.
Yeah.
So just going back to the next landing on the moon, Lee, you've got some information on that you'd like to share.
Yeah, it was just hang on, am I unmuted this time? Yes, I am, because I was muted when you were answering that. It's the next landing site's actually, it's been chosen by NASA for the Viper mission, which is searching for fuel because or fuel components, because effectively that's where water will be, and that's the region. It's a mountainous region near the Nobel Crater or Nobile Crater, and that'll be going in 2023.
And there's been various probes over the moon, and they purposely crash them into craters, and then they look using telescopes and other instruments to see if they can see hydrogen rising after the crash, and that helps them determine whether there's water there or not.
Correct. Yeah. So that's effectively what they'll be doing.
That's a very interesting.
Apparently Apollo 17 did some experiments to examine the atmosphere, and there are sort of whiffs of mainly neon, helium, and hydrogen. But it is whiffs. It's not a real atmosphere, if you like.
It's a pretend atmosphere. Now we've got a question. Michelle wants to know. I'm going to see if we can get that up. There we go. What is the dark grey line at the bottom right of the moon? Now, if it's what I think she's talking about, which is the sort of...
It's one of the Mare Frigoris.
Yeah, and that is, Mare Frigoris. We were zoomed up on there earlier with Noel's, when Noel had zoomed in. So that's Mare Frigoris, which we were having a close look at before. And I've got... Noel's got a lovely little crater up for us at the moment. There it is, which is the Landsberg Crater, which is not far from... Actually, there's two craters you can see in there. One's Reinhold and the other one is Landsberg. And Landsberg is a lunar impact crater. And it has a high rim and a central mountain, and the terraces along the inner walls and the tops have slumped to produce sharp edges. Now, Barry, did you have any information about Landsberg or Reinhold that you'd like to share? Or
not immediately. I'd have to look them up.
Google is your friend.
Nothing off the top of my head.
Nothing off the top of your head?
No. But
well, that's nice and bright there, Noel.
That's on the edge of Mare Crisium, is it? Or no?
It is, yes, yes. We have another question about Moon's atmosphere. Is the solar wind a wind that could blow dust around on the Moon?
No, I don't think.
I wouldn't think so.
It's an interesting question, but I don't think so.
Yeah, it's a good question. Nice question.
It does have an effect on charged dust.
On what dust?
Charged dust. So anything that's like when you get static. So charged particles that adhere to dust or dust adheres to, it could affect them. But I suppose if you're talking dust on the Moon, it's a question of what's moved them around to cause any static. Maybe whilst the if there's anything that impacts, that would be have a bit of a charge to it, or when the astronauts were there and moving things around, they would have caused static. But I think ordinarily not that much, and probably to insignificant portions.
Hopefully that answers the question.
And the Earth is protected from solar wind by our Van Allen belts because of our magnetic core.
Mark?
Yes.
I have a small item of interest that the viewers may like to research themselves.
Share away.
Well, it's concerning what we call the full moon. Now, the full moon as we know it, if we could go a long way north or south of the Earth, is when the sun and the Earth and the moon lie in a straight line. And the next full moon, that of course is an instant in time. The next full moon is October the 21st at 1 hour, 57 minutes, 39 seconds. And that's when the lineup is straight, to put it in those terms. But there is another full moon that when the moon is full, of course, unless it's a total eclipse, it still shows a phase either north or south on the limb. And a second full moon, which is very rarely referred to, is when the moon is maximum illumination. And that occurs probably at a slightly different time to what we commonly call a full moon. Now, there's a third one that may interest some people. We work out the date of Easter as being the first Sunday after the first full moon after the vernal equinox, or our autumnal equinox. But it's not the full moon as we know it. It's called the ecclesiastic full moon. And it's a full moon based on religious periods dating back hundreds of years. And as it turns out, I think it was in the 70s, it actually made a difference. It kicked the moon over 1 month from what we would have called our own astronomical full moon. Using the ecclesiastic full moon, Easter was made a month later. So if people would like to research what the ecclesiastic full moon is, that would be an item of interest.
Well, there we go. Bit of homework for our viewers. Go and do some research on what an ecclesiastic full moon is and come and report back to us.
It probably won't make a difference for another couple of thousand years, but in the 1970s, Easter was actually made a month later because of the ecclesiastic full moon.
I think what we might do, Barry, is if anybody wants to go and research that and send us in their thoughts on it, I'll copy and paste them and send them over to you for grading.
Yeah.
You can grade them.
Yeah, right. I'll set an exam on it.
Here we go. Set an exam on it. Do your research. Barry's going to set an exam on it. Now we have
What
an
are the
interesting. Sorry,
what's the image we're looking at the moment, Mark?
That's Knowles.
Knowles, yeah.
Yeah, I finally found the Landsberg Crater. So that's this guy little here.
Oh, okay.
Yeah, the little one right towards
Yeah, they're pretty close to Copernicus.
They are, yeah.
Is this using Noel? Is this using your 180mm Mac?
It is. Yep. Well spotted.
Excellent stuff.
Beautiful and sharp, isn't it?
Very sharp. Now, interesting question has just been posed. I find it amazing how the moon is transparent. During the day, you see blue sky right through it and around it, and during the night, dark sky. Now, there is a reason that it looks like that, isn't there? That it looks like you can see through the moon. And I always talk about when you take a photo of the moon during the day, it kind of looks blue and not as bright. And
you can actually take images, Mark, of Venus and Jupiter
during the day as well. But
during the day,
What he's trying to ask is, why does the moon look blue or almost look transparent during the day but not at night? So what causes that? And I would say it's the fact that it's daytime, obviously in the sun.
I think it's atmospheric scatter.
Atmospheric dispersion.
I think it's scatter because during the day the atmosphere scatters more blue light, and so therefore it makes the moon look a bit transparent, but it really probably isn't.
Yeah. So I've taken photos of the moon in the late afternoon when it's looking that blue colour, and when you process them and sharpen everything up, it just looks like a nighttime moon. So yeah, it's not that it's transparent at all.
And you can actually see Venus during the day if you know exactly where to look.
Well, you can see Jupiter and Saturn as well.
Yeah, with a telescope, but
with a telescope, yes.
From just naked eye, not only can you see the moon, but you can see Venus. Not easy, but you can.
Okay, so I think Gerald wants to have a bit of a chat about eclipses.
Lunar eclipses or solar eclipses?
Well, that's up to Gerald. He's hiding in the back end of the stream.
No, I was thinking maybe we should talk about eclipses because you can actually get, it's quite a spectacle to watch the moon go from something that's quite narrow to something that's quite amazing, nice and red.
So, do any of you guys have any of your eclipse photos handy that we could share with the viewers and have a chat about it?
Yeah, I've got some, but they're not exactly handy. Give me a couple of minutes and I'll.
Yeah, same. Give me.
Anne-Marie's got one sitting on her desktop, so we'll just pop that one up to start with. Anne-Marie, do you want to tell us a little bit about how you took this image of and what eclipse it was?
This was the moon eclipse. I can't remember when it was. It was earlier this year. I just took a whole heap of shots, and this is just one that I happened to like, just right at the very end before it was total. So, yeah, it's just on my desktop because I liked it.
So Stuart,
when a lot of us were at Caulfield.
We were at Caulfield, yes, and we actually had some great viewing that night. Just before lockdown 5.0 started.
Yeah, March, yeah.
It was the day before.
I've got a sad dad joke.
Yeah.
How does the man on the moon cut his hair? Eclipse it.
Oh, eclipse it.
Oh no!
Wow, that's a granddad joke. That is.
That's almost worse than most of mine.
Stuart, would you like to explain a little bit about the two different types of eclipses that we've mentioned, solar and lunar?
Yeah. So in the evening when we have lunar eclipses, which is almost yearly, is when the Earth passes between the sun and the moon, and very slowly you see the edge of the Earth move across the moon until it's totally blocked, and then the moon turns red because it gets the reflection of the off the Earth back onto the moon, and it's mostly in the red wavelengths, and so it looks quite red, and until it then starts to go back over the other side out of eclipse. And then a solar eclipse is when the moon moves between, comes around and blocks the sun. Hang on, I've just got to try and think here.
Yeah, you're right.
The Earth, blocks the sun from, the moon moves across and slowly blocks the
sunlight. Yep.
Yep, the sunlight, and until we get that 1 to 2 minutes total eclipse of the sun, and until it comes back out again. So that happens during the day, but a lunar eclipse happens in the evening, or at night. At night.
Am I right in thinking that we've got before the end of the year, we've got a lunar eclipse, or a sort of partial lunar eclipse, and a partial solar eclipse coming up? Anyone know? I think I was reading something in Sky and Telescope. I'm sure it's before the end of the year.
I've got a feeling it's a very low horizon one.
Yeah, that's right. I think the if I remember the article, it said that it's because there's a full solar eclipse which will be observed by many million penguins in Antarctica. I think that's what the article said, and we get a partial eclipse here in.
I'm wondering if they'll have their telescope gear set up down there.
So it said many millions of penguins and a few hundred people. So that's the people based at the Antarctic stations.
Now we've got a video here from Caulfield from when we did our live stream of Caulfield. This is live video that we captured on the night, that Lee captured on the night for us, and he's going to try and speed it up to show the eclipse.
Going 4 times now, so
still moving very slow.
No, we might go faster. That did sort of take an hour to occur. Where are we speed? Hang on. There we go, 8 times.
There we go. Can I go 32 times?
I might have to, yeah.
Did you take this at Caulfield, Lee?
Yeah, this was Caulfield. This was actually using a HD, a 4K broadcast camera I use for videoing football.
This is the one that we had streamed on Facebook and YouTube. This is the footage that we were using.
Yeah, it's actually coming up a little bit blocky because of running it at 16 times.
So you can see it's about to hit there on the left-hand side.
Yeah, and it doesn't, when you look at it, in fact, it doesn't quite go 100%. So
no,
even though it was a total,
yeah. It didn't,
and the other thing is, you'll notice the moment it sort of gets to that point, though, I did up the gain on it, and not long after is when you actually see Antares, I think, behind it. It looked like we were going to eclipse Antares.
Yeah, because as eclipses go, it's a very short one, wasn't it? Because the moon was very close to the edge of the umbra.
Correct.
And it was interesting because it wasn't quite total.
Yeah.
So there was a shiny edge to the moon during the whole event.
And I had this was actually, as I said, I had my telescope and mount and everything set up, and I don't think we actually went to viewing through my telescope. This was all viewed on a we had the projector screen there for public viewers, and they were all watching this rather than what I had on the from the telescope. This was just from a video camera. So you can see Antares down the bottom there.
Yeah. Wow, look at that. Was this the last in-person event that we were able to do?
Yeah, 26th of May.
Yeah, I can see the date on there. 26th
we
of May.
We went into lockdown 5.0 the next day.
Yeah.
That's right.
Which we came out of for a whole 8 days and then went into the current one.
Yeah.
All right, so I think we've, unless anybody else has got anything else they'd like to share, hang on, we'll just jump across to Gerald's here.
Oh, look at that.
There we go. Have a look at that.
That was the other thing I was a little annoyed at. For the, like, we did everything we did, which was the streaming is fantastic, and yeah, we had Stefan there doing special comments, but I didn't get one photo during the whole eclipse.
And you can see it was never quite total.
Yeah, this one was taken the previous one. Yeah, I'm the same as you. The last eclipse we had, I wasn't prepared for it. My gear failed yet again.
There we go. That's a beautiful.
We did a lunar eclipse before that in the city on the Princess Bridge, and that was a really good one. When was that? 2019 or
was that when the moon went a lot redder?
Yeah. That was a very good one.
Yeah. So Anne Marie's got another one. So here we go. I think we've finished with the live streaming of the moon. We're now reminiscing about lunar eclipses.
Guess what I've nearly got too? The moon.
And we're finishing the stream, and Lee's finally got clear skies.
Well, yeah, almost.
Well, there you go. This is a beautiful shot. So you can see the full moon heading into eclipse and then coming out of eclipse. And I think that night at Caulfield, it came out fully out of eclipse, and as it came fully out of eclipse, the clouds finally came in and closed the night out for us, which was pretty interesting.
Which was how it started before we even got there.
Cloudy, cleared the eclipse, and then ended cloudy.
Yeah, the timing was pretty perfect. We had a really good night.
Very perfect.
I'm so looking forward to getting back to those kind of evenings.
Oh, well, we're nearly there. We're, a week and a half, or just under 2 weeks away, week and a half away at this stage, 2 weeks away. So we're not far off being able to go and do those sorts of things again. So I just wanted to, before we finish up, just let everybody know that we have our Vic South live stream, which is the weekend or days before we get full freedom and are able to travel throughout Victoria again. So we will be back for that. It's a weekend extravaganza starting on Friday night with Sky for the Night and Lunar and Planetary, astrophotography on the Saturday, quiz on the Saturday, discussion about or a presentation on comets before we get into deep sky. And then on the Sunday, we're going to look at solar eclipses and have a solar live stream. So we'll share the sun with you on the Sunday of the weekend after weekend of Cup weekend. There you go. So the weekend of freedom.
Halloween weekend.
Halloween weekend, yes. Yeah. Halloween weekend. So we have a raffle for that one currently happening at the moment. That raffle has two prizes. First prize is a Skywatcher Star Adventurer mini kit valued at $699. And second prize is a telescope carry bag. It's about 40 inches long. It's heavy duty and it's valued at $299. Our raffle ticket links are on our Facebook page. If you'd like to grab a raffle ticket, all the money goes to our Pathways to the Planet project, which is actually under construction at the moment, which is great. And we want to thank TSA Outdoors for sponsoring that particular stream. Tonight, I'd like to thank you for joining our live stream. Say thank you to Optics Central for sponsoring tonight's event. Congratulations to our two winners. And we hope to see you for our Vic South live stream. And if you're not a member yet, and you're interested in becoming a member, go to www.asv.org.au/join. Once again, if you don't follow us on Facebook, please do. And if you don't follow us on YouTube yet, hit the subscribe button. And we hope to see you in a few weeks for our Vic South live stream extravaganza.
What I want to know is, can Gerald play us out with a tune?
Can who play us out with a tune?
Gerald, you got the piano.
Gerald.
Oh my god, I'm not connected. All my stuff.
Excuses. It's always the way.
Just nothing will get a copyright strike for.
We might get a copyright strike. Thank you to everyone for coming along tonight. Thank you to our team for joining us and helping us stream the moon and answer your questions. And we'll see you on the weekend of Freedom, or the weekend just before Freedom, Halloween, for our live stream extravaganza. We'll see you later.
Excellent. Thank you.
See ya.
Nice.
See ya.